Recording in progress.
All right. You can still hear me, right?
Yeah, I can.
Okay, great. Let's start. So what we covered with Partho last week, and basically it was just a casual conversation. We are just starting to learn a few things about data lifecycle in general, how things are, and where the roles of different data, uh, roles in technical industry lies. So basically, if you look at the data lifecycle, it can be divided into few pyramidal structure, right? Which has some foundation and then it builds up. So if you look at this particular pyramid that I'm pointing here, right?
Hmm.
So initially, any data lifecycle that starts with data collection, right? And then
Hmm.
then there is a strategy of how you want to move or store the data. Then you basically do data exploration or data transformation. Then on top of that sits your analytics, and then on top of that sits your AI or machine learning capacities, right? That's the very generic outcycle.
Hmm.
And then,
Hmm.
then you
Hmm.
can obviously argue that there are a lot of other things that goes on there. I mean, I'm not going into the super detail out of it, right? So
Hmm.
based on this, it's like 5,000 feet overview of how it will be. I mean, from a bottom-up approach, if you look at things, the roles in the industry can be divided into three categories out here. One is data engineering, which is here.
Hmm.
One is
Hmm.
analysis, another is the data scientist, right?
Right. Hmm.
So the first layer, the second layer, and the third layer comes in the purview of data engineering, right? The analytics layer is typically your, lot of places, the analytics and exploration layer is a data analyst kind of role. And then the data science or machine learning sits on top of everything, which is AI based, right? So the point I wanted
Right.
to make here is that in a typical pyramidal life cycle that you look here, right?
Hmm.
Mostly in a data life cycle, the journey or the most effort that is being taken by people on or to have that kind of a good business outcome is to clean, transform, and store the data, which is the responsible for the data engineer, right? So
Right.
in a five layered structure, two-thirds of it, i.e., three layers, actually belongs to data engineering, which is obviously, I mean, more than 60% of your whole tech stack that or of it belongs to it. Now, that does not mean that data engineering is superly important that will generate all the value.
Hmm.
Data engineers brings clean, stored, and explodes the data as per the requirement given. But on top of that, if the analyst team or the scientist team doesn't go and churn out the value of the data,
Hmm.
then obviously the whole thing it doesn't make sense, right? So the
Right.
in terms of importance or the business criticality, it's quite the reverse arrow. In terms of the work, it is quite the up arrow. So reverse arrow in that the most business facing role are the data scientists, then the analyst, and then it comes the data engineers who can explain the behavior of the different organizational leadership, where the data is coming from, where the data
Hmm.
life cycle runs. So those are
Hmm.
typically the data scientists are engaging with a lot of leadership discussions, right? And then
Hmm.
you have data analysts who engage, and then we have data engineers who typically engages with the other two layers, which is like data analyst and data scientist, but they don't directly, they do generally interact with business, but not that much business criticality. This part it is clear, right?
Right.
Okay, great. So let's just move ahead. So what we wanted to also take a deep dive at is basically, so why is this not scrolling? I don't know. Let me see if there is a problem out here. Okay.
It is not scrolling after a certain. Uh,
Sure. Why? Let me kill the app and bring it. Let's see. Yeah, now it's fine. Okay. So what we wanted to look at is that how is this different data lifecycle does give life rise to all these roles. We are pretty clear about that,
Mm,
which is something we just talked about, right?
mm,
Which
mm,
is typically up till this, right? Now
mm.
let's talk about few things which are very critical to understand. One is how data is generated and how data is stored. So when data is generated in a business scenario, it gets generated in a transactional processing system. We generally call it as OLTP, right? What is OLTP? It is the application database. Whatever your application is, it is actually pushing in that data to
Mm.
that particular database is called OLTP. Any questions?
No, okay.
Okay, so your application database needs to have certain attributes or characteristics. Now,
Okay.
those attributes are not necessarily going to be the same use case for your analytical purpose, right? For example, your application database is something that has to insert data to a table more rapidly, right? Lot of people interacting with your application, lot of people are generating data.
Mm,
Those
mm,
applications need to write data to your database, right?
mhm.
So insert, update, deletes are very common, right? Uh,
Right.
and in this case, what happens is that this kind of thing which are happening in the insert, updates and deletes, right?
Mhm.
This kind of does this kind of behavior of the application does not allow us to directly get the data from transactional processing system and put it to the data collection layer, right?
Okay.
Because if we
Okay.
directly do it, then
Mm,
one side, say there is an application here, there is an
mhm,
application here,
mhm,
right? There is a business process that is writing the data, and you are
mhm,
also generating it to a table for
mhm.
analytical purposes, right?
Okay.
Now, what happens is that this creates a very bad architecture and it creates a blocking, right? Because what would happen is that this guy, when it is
Mm.
trying to insert the data, at the same time you are trying to read the row. So when that insert will
Okay.
happen, it is going to create an exclusive lock on that table, right?
Right.
And then at the same time, if you're trying to fire a query in order to read that data, it is going to slow this process down, right? So that is why
Okay.
we want to, from an architectural perspective, this is very critical to understand that we want to keep these layers different. Okay, is it clear?
Mm. Right.
So,
Right. Right. Because the analysis
analysis happens
happens
on
on the separate layer rather
separate
than.
layer altogether. And why
Okay.
it happens, we'll go there, right? Slowly we'll go there. And the
Mhm,
thing is, why it is happening that way is because your OLTP, when it is like mainly your transactional processing system, has certain
mhm,
attributes we just discussed, right?
mhm,
This thing has to be insert optimized, and we say that these databases are highly normalized or in a database or in a 3NF form, right?
mhm,
What happens, we know that there are a lot of, I'm not getting into that normal forms right now. Someday, if we
mhm.
require, we can dive into
Right.
that. But
Right.
it's a
Mhm,
generic normalization is in a 3NF or it's a normalized form. What
mm,
happens is that, which means that there is a lot of tables in here. There might be a user table, there might be a transaction table, there might be a product table, there might be a, I do not know, discount table, right? So these tables are interconnected with each other with some primary key and foreign key, which means what? Which means that there are more joins that you need to write in
Relational
order
database.
to, sorry?
A kind of relational database, like there's a
Yeah,
relation like
typical
between.
typical relational database, but relational
Right.
database is more of a concept, right? Both are relational databases. We will just talk
Right.
about the OLAP shortly, but the
Mhm,
architecture wise, just understand this much, that when we are talking about this kind of an architecture, what we are
mhm,
basically saying is this OLTP side of things, right? This OLTP side of
mhm,
things when it is generating, in order to select data from any one table or a group of table,
mhm.
you have to write a complex query, which is going to have lot of
Right.
joins because
Right.
it is
Right.
normalized, right?
Mm.
Then what happens is that, look at that query. How does the query execute? That query execution time becomes very heavy because you are actually hitting 3 or 4 tables in order to generate a 10 column data set, right? And that
Mm,
query execution, when it becomes very heavy, what it happens is that your retrieval of the data becomes very slow.
mm, mm.
You got this point very clear, right?
Right.
Why,
Yep.
what is the
Yep.
OLTP side of things?
Yep.
Let's now talk about OLAP. In order to solve this problem, online analytical processing architecture came into place, or paradigm came into place. Now, the one thing that it solves is that this is optimized for analysis. How this is optimized for analysis is because it is optimized to return data fast. That means that it is optimized to get the select query executed faster. In the right hand side of my screen, you see that there are more joins. Tables are actually
Mm,
segregated between
mm,
four tables.
mm,
Obviously,
mm,
it is going to take more time. So it was normalized. What we do opposite on the normalization side of things on OLAP is basically
mm.
denormalization. So we join in order to put the data, but when the data is stored into the database, there is a flat white table, very big table which has all the data. It is not
Okay.
normalized. It is not normalized. It has user data, it has transaction data, it has product data, it has discount data, everything. Now there can be scenarios that few of the columns on this particular data is null, and we are okay on that having it as null, because
Okay.
we are going for denormalization, right?
Right.
Why we are going for denormalization? To optimize this guy, select, which
Mm,
means that
makes
there is
sense.
no join,
No
right?
giants. Yep.
If there is no join, then my read becomes faster and writes become slow.
Hmm. Right.
Is this concept clear?
Yes, read becomes faster, right? Exactly, because its reading time is very
So
less on this one.
any of the analytical database has to be on OLAP. Any of the
Hmm.
transactional database has to be on normalized. Is this
Right.
is this clear?
Yep.
Any
Yep.
questions?
Yep. No, so far so good.
So far, so good, right? So for any of the analytical use cases that we see, right, the the journey of ETL is basically to go from OLTP to OLAP.
Hmm.
In between, there is a data pipeline. We take data from OLTP and we put it to OLAP, right? And we call it
OLTP to OLAP.
because the data was
Okay. Okay.
there on the business side of things. In order to
Hmm.
have the data surface to the data scientist and the data analyst, we have to bring it to a lab because they are quality, and because of this reason, right? Because of the reason right here, that it is going to
Hmm.
it is if we put it onto the same database, it is, we just talked about it, it is not going to be very much performance efficient. So we are going to
Right. 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 Right.
get the data out from the OLTP. We are going to bring it to a lab, and so it becomes the select query is optimized. There is no join, and
Hmm.
the read becomes faster, write becomes slower. So any of the data
Makes
analysis or
sense.
data
Hmm.
science effort, when it is done on a OLAP database. Okay. The OLAP, OLTP to OLAP transformation is
Hmm.
typically
Hmm.
done through a process called ETL: extract, transform, load. Extract from OLTP, transform the
Hmm.
data. That means in a very childish way, we can just say that
Hmm.
get all the join queries, so that in that is getting, joined in such a level that we there, and we load it to OLAP,
Hmm.
right? And this is
Hmm.
typically the job of a data pipeline that it does.
Right.
Okay. Are you
Right.
clear?
Right. Right. Yes. Yes. Absolutely.
Okay. Now just talk about two things here. So there are two concepts. One is ELT, which is extract, transform, load. Another
Hmm.
is, I use this not writing. Okay, yes. Another is extract, load, transform. So
Okay.
which one is better for which use case? ETL versus ELT. Okay.
Okay. Okay.
So now think of it. You have a data, uh, an analytical use case where I am asking you to write a query on your user table to give
Hmm.
me the count of ID by date. So what will be your query? You will actually just select a date function here. I mean, it can be any of the date columns in this, right? And you can actually count the ID, and from user table you will do a group by one, which is
Group by.
between group by this the for the
Hmm.
first the
Hmm.
first date column, right?
Hmm. Hmm.
So what happens in this case is that this query, if you break it down, right? This query if you just look at it from that perspective, if it was a user table which is having, say, a timestamp, a ID column, and count of whatever we can do, we can just count, right?
Hmm. Hmm.
We are basically interested to find the count of users by day, right? What happens
Hmm.
is that in case of an ETL pipeline, if you look at it, right,
Hmm.
your in order to get that query valued, right, your transformation will your transformation needs to lie in the middle, right? Because you are transforming the data into the middle. So once you extract the data from OLTP, right,
Hmm.
you put this query and then you basically get that data and then you write it to the target database. So if you are following my pen here, so this is step one, which is
Hmm.
basically your query is on the transform layer, right? You are firing the
Hmm.
query to your extraction database. You are
Hmm.
basically getting the data, which is basically, I mean, basically you are actually storing and retrieving it. You might
Hmm.
want to use a storage here or whatever, and then you
Hmm.
basically write this to your target system, right?
That's the loading
To
part. Okay.
loading
Okay.
part.
That's how you're
So
setting from the OLTP to OLAP.
yes, so this
Step
is
one, two,
ETL
three. Okay.
one, two,
Okay.
three. So this is a source, this is query, this is destination.
Mm. Okay.
Think of it,
Okay.
if my instead of transformation into the middle, what happens if I extract all the data and dump it to one target database in the first place? What would be the optimization? The optimization is that uh, whenever one second, parts. Okay, so whenever we have this kind of a scenario, right, we have to
Mm-hmm.
see that this ELT kind of a thing basically is
Mm-hmm.
telling what? We are extracting the data from OLTP system. We are loading whatever is there to the target system, right? Then performing the transformation in the targeted database. We are not performing the transformation in between. Are you clear between ETL and ELT?
Okay. Okay.
ETL is what? ETL is what? ETL is extract, transform the
Extract,
data,
transformation,
transform,
load.
load. ELT
Right.
is what? Extract,
Track.
forget about transformation,
Hmm.
directly load the data, then transform the data.
Oh, okay. Okay. And why do it's just for optimization
No,
purpose, right?
I'm just telling you why. Now, if you look at the same query,
Mm-hmm.
you have to run the query only in one place and get the result, which is already the data is loaded into your target database. This is still the source. This is the destination. Now the query runs into one place and gets the data. So in place of three operations, you can optimize this into two.
Okay. 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 Right. Makes sense. So one lesser operation, lesser time.
One lesser operation, lesser time, more performant, lot of benefits.
So,
Okay.
in general, I mean, maybe going ahead of time, but in general,
Mhm.
then we should always go for ELT, right? But as a
There is
thumb rule,
a
it's but there
there is
has
no
to be
thumb
some.
rule. So in data engineering or in any of the engineering use cases, see,
Mm,
the main thing is it is all architecture dependent. You as a data architecture have to
mm,
think of it based on use case. Now the use case would govern that what kind of architecture that you want to come up with. Now it is not necessarily that you want to always go with ETL point blank. It can be that
mm,
it can be ELT in some use cases, ETL in some use cases, but that is depending on the use case which you would be working on, right? So
mm, mm,
there is no, I mean, ground rule, or I would say there is no nothing set in the ground that you need to do it this
mm,
way versus the other way.
mm.
Okay.
Makes sense. Yep.
Okay. Okay, till this much, are you clear? Any
Y-
questions? Are you
No,
having any confusion? Am I going too fast? Am I not able to explain?
no. So far, so good. I mean, thanks. Actually, these are like more like a clarification of my understanding. So I think I'm so far, so good.
Okay. So few of the data engineering architectures, we'll just talk about this, is basically then is divided into some layers or layers of architecture. So when we talk about ELT in general, we have to extract
Mm,
from a source database, we have to load it into a target database, but we
mm,
are not going to directly use that data as is, right? There has to be an
mm,
architecture principle which we have to set up, and these are all imaginary principles that we set up, you can argue that, you know what, once I just load the database, I can
Mm-hmm.
give it to the data scientist and they can take it from there. Absolutely
Mm-hmm.
fine. But one thing that comes in engineering is not only development, but also maintainability. How do you maintain? And the difference between good architecture and bad architecture sets the difference between good maintainability and bad maintainability. So if you have a good architecture, if you have good guidelines on the system, it becomes easily maintainable, scalable, highly performant, fault tolerant, whatever you put it, reliable.
Mm-hmm.
Everything is following that kind of a principle. So that is our next discussion topic. So we kind of try to divide this in our mind into few layers of data. The first layer is called raw layer. Okay. So this is
Mm-hmm.
the layer where the data lands from the pipeline, say from your ingestion pipeline. It just
Mm-hmm.
lands into the first landing space I've just written here,
Mm-hmm.
first landing space, right? And it is a replica copy without any transformation. Whatever data is in source, you just land it there.
Makes sense.
Just
Okay.
dump it there because we are doing
Mm.
extract and load, right? So
Right.
you are completing with this two procedure. Your extraction is done and your loading is done, right?
Right.
Now you can directly say that I'll go and transform the data, but there has to be a clean layer between it, which will work on these set of tables on the raw, do a data quality check, whether those are actually duplicate data, whether they are actually having primary key constraint violation, whether all data is fine or not. And then it will actually give the control to the next layer, right? So either you can copy a bunch of table from raw to clean, or you can basically want to do it on the raw layer itself. I mean, there are different other methodologies to do it, but generally that. So there is a concept in data warehouse called slowly changing dimensions, SCD, right? So
Mm.
typically on the cleans layer, we go with SCD2, which is date governed, which is like you have a start date, end date kind of a thing, right? So we are
Mm.
not removing any kind of a row in case of an update. We are just persisting that update, and we are persisting the previous value, and we are just upserting, or sorry, not upserting. We are just inserting that with the newer update as a new row. So that is called SCD2, right? Now, the third layer that we have is basically the matrix generation layer. Now people
Okay.
in different organization call it differently. They can call it, I mean, pre-API layer, they can call it foundational engineering layer, they can call functional engineering layer, they can call it metric layer, they can call it analytical layer, whatever. But typically this layer is meant to have the data in the analytical use cases. So this is where you as a data engineer would get requirements from your peers of data scientist or data analyst, take the data from the clean, and you basically write SQL query or Python logic, whatever, to generate their expected output. That might be, some KPI generation, that might
Mm.
be feature engineering, that might be, cleaning up previous table in such a way that we want to also, retain certain things. So this is the layer that we do it, right? And it has
And
all
this
the
is basically, I'm sorry, but this basically completes the transformation from the OLTP to OLAP. This is
yeah,
where
this
overall
is
the
where
things come.
ELT is done. So E was
Okay,
done,
ELT is done.
E
Right.
is done, right? Now after that, you basically do not allow direct access for the data analyst and data scientist for this layer. You copy the essential ones that are needed to another layer, which is called presentation, and you give
Mm.
the user exposure. So this is typically called a API layer. It can be APIs, it can be tables, it can be views.
Okay, right, right, right.
So
Yeah.
what happens is that there is a concept called RBAC. RBAC is what? Role-based access control. Role-based
Okay.
access control would
Mm.
only allow roles of data analyst and data scientist to access the presentation layer, right?
Mm.
Engineers to access all the layers, right? So what happens is that as a part of the engineering or data engineering org or whoever, then data engineers are responsible for the full process of ingesting the data, transforming that data, cleaning that data, and coming up with the metrics. And whenever that matrix is needed to be exposed outside. It can be exposed as a part of the API, part of table, part of view, but it's a controlled mechanism. That's why there is a separate schema or separate layer altogether, which is presentation layer, where we are putting the data. Is it clear?
Okay. Yep. Makes sense. This is
Good, 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 good.
connect a lot of dots actually today.
Okay, so we will pause of our recording. Let me pause it.
Okay.